What we're going to look at here is kind of a way of organizing our thoughts when solving problems. One of the things that we do in mathematics is we map reality into this new abstract language of mathematics. And so to do that, we kind of have to have some ways of mapping reality to this abstraction. And there's not always some set ways to do this. Polya, a mathematician, came up with he wrote an excellent book on how to solve it, where he kind of tried to distill the process. And what you're going to see here is the distillation of that process in what's called the four-step problem-solving process. And so for us, the first thing is to understand the problem. Okay? Notice how loose this is in language. Understand the problem. What that means is to try to get a mental image of what the problem is talking about. So we do this, we read the problem several times. Now, one of the things I notice when people do math problems is they'll read it and they immediately begin looking for the numbers. And I think the part in our culture, we're taught to test quickly and to quickly come up with answers. And so we'll look at the problem and we'll pull all the numbers out. That doesn't work. And reading problems, the word problem, which everyone seems to hate, is kind of artificial. It's a thing within school to teach us the habit of looking at reality and turning reality into a math problem. In the real world, we don't always get it given to us in words. We have to write down the words. And so it's better not to look for the things to pull out, but to find a methodology of how to map things to numbers. And so one of the things in understanding the problem from a word problem standpoint is read it several times. Turn it into something real in your mind, or more real than words. First time, read it, get a concept of what's going on, and the second time, kind of organize the information. Don't go right for the numbers, but for me, I don't always write down what information is going. I'll sometimes draw pictures. If there's people involved, I draw little stick figures. I group them together or group them apart to try to get that picture of what's happening, some mapping between it and reality. Then devise a plan. We'll look for a pattern, make tables, estimate, make a guess, try to make it look like a problem I already know. And this is one of the most common things in mathematics is if a problem has one form and that form is similar to something else, try it and use trial and error. Try some things and see if they work or not. And so you might have to go through different one of these. Again, a lot of times in our system, because we're teaching multiplication, you'll get word problems where you only multiply. And so the plan is given to you just from the context of what you're learning at the time. But in the real world problems, you have to have different ways of solving the problem. And we'll look at one of those shortly. So devise a plan. Figure out what you're going to do. Make a sketch, which I usually do in my reading part, in the writing down. But you also, when you go to solve the problem, you can look at the sketch or make the sketch to solve, make it active. List the information in a chart or table, sometimes organizing the table, make a graph. Look for a catch. If the answer seems too obvious, look for something that could be wrong. And eliminate things that don't make sense. Use common sense. I'm not a fan of use common sense, not because you don't have common sense, but we tend to use this as a catch-all for when we don't want to learn and update our common sense. Because common sense really is a sum of everything you have learned so far. And so you don't want common sense to stop you from learning new things. And we'll see there's some things in probability and statistics that aren't intuitive to human beings. And if we relied on common sense, sometimes we would miss things that come out in probability that we just don't have a gut feeling for yet. But if you add that to your list of knowledge, you can eventually add it to your common sense. So I'm going to put a caveat on common sense. Be careful with common sense. Once you have that plan, carry it out and get an answer. That's usually the easiest part. This is the part where I get a lot of people go, I was really, really good at maths, but I'm having a problem in this course. It's usually because they're very good at carrying out the plan to solve the problem. Given a formula, they can plug the numbers in and get an answer. But not giving a formula, choosing the formula, or making the formula gives them some difficulty. And then you want to look back and check the answer. Does the answer do what you need it to do? Does it make a good prediction? All right, we're going to go through a couple examples, and then I'll do more examples based off the questions that people have with the homework on this. So, a man purchases 5 shirts, each at the same discounted price. How much did he pay for them? So, understand the problem. Now here, they're jumping right to the numbers. Here's what's given: number of shirts purchased, and how much we paid for the 5 shirts. Now here's the deal though. I'm actually in my head seeing me going to a store and what I do all the time. Oh, these shirts are on sale. I'm going to buy 5 of them. I don't have to buy shirts for the next 10 years because I've got 5 now, right? And then I end up wearing the same type of shirt every day, and people don't think I changed my clothes when I'm just wearing the same shirt. 5 different versions of it. Right? And so how much do you pay for them? So for me, what I see is 5 shirts. Right, I'm trying to make shirts here. They look more like chef's hats, I guess. And each of them have a dollar amount with them. So in my mind, I'm seeing myself, yay, shirts, because my stick figure's not wearing shirts. Gathering them up, going to a counter somewhere, and putting my 5 shirts down a pile, and handing over money to a cashier. Right? So in my mind, there's an active process going on. Now notice what I've done and yeah, this seems overly basic, but I'm trying to walk what's going through my mind. Because if we want to think mathematically, we're organizing this word problem into something that actually happened. And I'm trying to link it to everything I do with what's happening. Now, I don't know how much each shirt costs, but I know it's the same price. And so I know whatever that price is, I'm going to pay 5 times it to the cashier. And now my math is starting to show through. Because if I can name that discount price X, I'm going to pay 5X. That's going to be my total. And so the picture went into a process, and the process told me the math that I was going to have to do. And in the end, well, my total price is going to be 5 times whatever the discounted price is, if X is the discounted price. Discount price. And T is my total. And we sometimes have to do that. We sometimes have to sketch the whole problem together. And so we devise a plan, 5 times the cost of each shirt. The discount price is not gone. Makes it impossible to solve the problem. But look what we did. We didn't make it impossible to solve the problem. We came up with a formula that if we get this one piece of missing information, we plop it in and we're good to go. Alright, what I'm going to do is, this is kind of the core of Chapter 1. It gets us into what we're going to mathematically do. And what we're going to need to see is some examples. And so this is where the interactive part comes into this class, which is that as you get problems that you have, what I want you to do is I want you to ask me a question on them. What I want to do here is I want to try to get over where I can show this. So I'm going to come over to the web browser here, and I want to go to my Pearson. And so in Pearson, sorry, you're going to get to see all of my different courses, but I'm going to come into a problem set here, and then I'm going to do it in student view. So I'm going to do this as a student view. Interesting. View student home. And I'm going to come into a problem here. So I'm just going to pull up one question. And let's say you were working on this problem and you weren't sure what to do. All right, down here at Get More Help, there's Ask My Instructor. If you click on Ask My Instructor, you can type in, I tried doing this and it gives me the wrong answer. I did these steps, and list a couple steps, picked only the item that wasn't in the set. Some note. I'll get an email that will give me an exact copy of the problem you're on, and what I can do is I can record videos for the whole class based off the question using example problems. And so this way we can interact as if we were in the class with a little bit of delay. Right? It's how quickly these go through. And so that we can build our example sets out of this based off of the things that you want to see. So please use the Get Help. That'll send me problems, and then I'll come over and record little videos and fight with YouTube. And let me go back, get out of student view here. All right. So this is how we're going to approach. We're going to look at problem solving. I'm a very, very big fan of get a mental picture. Make it alive. And I shouldn't say mental picture, right? Not all of us see the same as others. So a mental model. And use that mental model to be dynamic. And in the dynamics and the changes going on, we can usually start seeing our mathematical processes.